Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. MCPBA is a peracid that performs SYN epoxidation of alkenes. The oxygen is delivered to both faces of the double bond simultaneously from the same face, preserving the stereochemical relationship of substituents. Moving on to the next step. Identify the starting alkene. The structure shown is Z2-butene, CIS2-butene, where both CH3 groups are on the same side of the double bond. Both H atoms on each carbon are shown, with CH3 groups implied at the top of each sp2 carbon. Looking at the structure, each carbon of the double bond bears one CH3 and one H, and the geometry is CIS, Z. The two CH3 groups are on the same side. Moving on to the next step. Apply SYN epoxidation stereochemistry. MCPBA adds oxygen in a SYN fashion. The two CO bonds form simultaneously from the same face. This means the relative stereochemistry of substituents is retained. In CIS2-butene, both CH3 groups are on the same side of the double bond. Upon SYN epoxidation, the oxygen bridges from one face, and the two CH3 groups end up on the same face of the epoxide ring. And for the final step, identify the product. The product is CIS2,3-dimethyloxyran, meso compound, where both CH3 groups are on the same side of the epoxide ring. This corresponds to option B, where both CH3 groups appear on the same face of the epoxide, one CH3 on top left carbon and one CH3 on top right carbon of the epoxide. Eliminate other options. Option A shows CH3 groups on opposite sides, trans epoxide. This would be the product from trans-2-butene, not CIS-2-butene. Option C and D show incorrect substitution patterns inconsistent with 2-butene epoxidation. Therefore, the correct answer is B. Therefore, the correct answer is option B.